Hi, and welcome to our next lesson. So at the end of the last lesson, I asked you to download the schema SQL that was provided in a download on the course website and go ahead and paste that into a window on db-fiddle and try running it. If you did that successfully, this is what you saw. You just saw there are no results to be displayed down below, and that's perfectly fine. That means there were no errors in what you typed, and there's simply no results because we haven't actually entered any query SQL yet. So we'll see results when we start doing query SQL in the next lesson. But in this lesson, I'd like to finish up going over the important pieces of information that you need to glean from the schema SQL. Again, we don't expect you to learn how to write this SQL. It will generally be done by either a DBA or data engineer, or in the case of the insert statement that inserts the data, that will typically be done by a web application. However, since we're pretending like we have a web application, we need to do that manually using this insert statement over here. So what I want to focus on in this lesson is data types. If we look at the create table statement, which begins here with the keyword create and ends with the end parenthesis here and the semicolon that ends the SQL statement. Each argument within the parentheses is actually a field definition for the table. So if we look at this first line here that's highlighted, this is for the ID field, and all this information pertains to the ID field until we get to the comma, which separates us from the next column to be defined, which is name. So if we look at the first word after the name of the field, which is ID, it is integer. And if you remember from math class, integer basically means a whole number. There's no decimal point, no fraction. So numbers like 1, 2, 10, 20, 30, so forth, whole numbers. Data types are important. They define what kind of data can be stored in a field. In this case, we're saying only whole numbers can be stored in the ID field. They also define what can or cannot be done with the data. For instance, if we just skip down for a second and look at name, which is the next field being defined, the data type is varchar, stands for variable character data. Variable meaning we don't know how long it's going to be. Character data meaning it's not a number. Even if we include a number in the name, which it may allow for, say, like a screen name, it's not to be treated as a number. It's to be thought of as almost like a license plate number. It doesn't mean anything. It's just a number embedded in some letters. It shouldn't be treated as a number. And that's why data types are useful, because it wouldn't make sense to divide one name by another. So it's not going to allow that to happen. The database will prevent you from doing that because it sees the data type as varchar. Whereas ID, that makes sense. You're dividing one integer by another integer, and that makes perfect sense, so it will allow that. Continuing to move across the line definition for the ID field, we have this generated always as identity. Well, the reason we have this here really comes back to the very reason why we have an ID field. It's really useful in a database table to have a field that is unique to that row. So it has a number, generally a number, can be character data, but generally a number for storage space efficiency, a number that uniquely identifies each row in the table. The benefits you get from that are speed when you're querying data. If you're joining two tables together, which we'll do in the future, it's faster if you have a unique field in each table. And also it prevents duplicate data from being entered as well. So we wanted to have an ID. We don't have a natural ID that the user can enter. We're not going to ask them for their social security number, which would be a good unique ID. So we're going to have the database actually generate it. And that's what this phrase generated always as identity means. So this is a qualifier on the ID field definition that tells the database that we actually want it to generate these numbers for us. And we want it to generate with a specific set of rules. We want to start with 1, so the very first row is going to get an ID of 1. Then we want it to increment that ID for every additional row. So the second row inserted, the second user that's created on the site will get an ID of 2. We never want those IDs to be used again. So if for some reason we delete a user from the database, we're not going to ever reuse the ID that was assigned to that user. So it's unique, just like a social security number is. So this phrase here tells the database to generate this number for us following those rules. The primary key qualifier here at the end is related, or better to say it's enabled by this generate always as identity. Primary key means this is the field that is unique within this table. So when I mentioned before that it's good to have at least one field that uniquely identifies every row in the table, that's called a primary key. And this qualifier is saying, okay, the ID field is the primary key for our table. And we're confident that that will satisfy that constraint, as it's called, because it's going to be generated by the database. If, for instance, we didn't have this generated always as identity, for instance, if we were having someone enter their social security number, the primary key qualifier for the ID field would make sure that no duplicates are entered. All right, if we move on to the next field, name, we've gone over the data type. And again, we can have letters and numbers in the varchar data type, but it will not be treated as a number. You certainly can't do math on names. The last qualifier on the name definition line here is not null. So null is a unique value in databases. It means unknown. Some people think of it as blank or missing, but it's really more correct to think of it as unknown. And we see, if we look down to the data for example, we see that Sylvester, who's on this second row of data, has a null age. So we allow age to be null, and that's why we don't have a not null on the age definition line here. But name, we do want the name to be required, so we make that a not null field. That way the database will not allow a row to be inserted unless a name is provided. Age is a integer data type, which is similar to ID, and that means that we can't store months or fractions. We're just going to store the years in age. So that's why we just made that an integer. And we don't have not null, meaning this can have a null in it. So if you look, this is sort of the minimum information that you need to define a column, the name and the data type. And this is the only column that has that bare minimum of information, but you do need at least those two pieces of information. Credit balance is the next field that we're defining, column that we're defining. And the data type for that needs to be a little different because we're going to store fractions, in this case, fractions of a dollar, otherwise known as pennies, cents. And so this is a decimal data type. The 9 means it has 9 digits in the number, up to 9 digits, and 2 of those digits come after the decimal place, which is what you need for up to 99 cents, right? $1.99, 2 digits after the decimal place. We also want to make this not null because we do want it to be required. Even if somebody's a brand new user, their credit balance is going to be $0.00. So there's no problem in making that not null. Date created is the last one. It's going to be a date data type because we don't want to store the time information, just the date that the account was created. In our scenario, the application would be creating that date when the user creates their account. And that's a not null field as well, because we know that if an account is created, then we know we'll have the date. And so that can be inserted. So that's the create table statement, the table definition. I hope you can see how that would be useful information to have when you're querying. You'll definitely see in the future how that's very important to know these things. The next statement is the insert statement. This actually is what inserts the data into the table. Normally these SQL statements would be run by the application, the web application that the user is using as they do things and create accounts and buy things. This sort of SQL would be run in the application to insert the data. but we can do it manually as well. So it's a very simple statement. Insert into the table name users. We list the order of the data as we're going to put it in the statement. So we're saying we're going to list name, age, credit balance, and then date created. The values keyword means after this is going to be the actual values. This line here is simply a comment that I've put in to line up some headers with each of the data columns. Totally unnecessary, but nice when you're looking at this data and you're writing queries in Query SQL. You can see each row of data is separated by a comma and is surrounded by parentheses, and the order of the fields is identical to the order that's expressed in this parenthetical grouping right here at the beginning of the statement. So the order certainly matters. You notice that ID is not expressed here, and that's again because we're generating that automatically, so we don't need to put it here. Finally, before we end this lesson, I wanted to point out you may notice that I've spaced things such that things line up nicely. I do that on purpose because when you're referring to the SQL, when you're writing your Query SQL, you'll often want to quickly find information. One of the great things about SQL is it doesn't really care about spacing or new lines or tabs. All that really matters is the order of the individual characters. So for instance, I can come in and put any kind of combination of lines and spaces and tabs. You can tab this over. Doesn't really matter. If we run this, it's going to run the same. So line it up the way that makes the most sense to you, and that way you can refer to it most easily when you're writing your Query SQL. Okay, we'll see you in the next lesson.